Hello, I'm Dr. Kelly. I have worked in the field of human clinical embryology and IVF for over 20 years. I will be one of your instructors today for the Art Compass Academy. Today's lesson is dedicated to understanding pH and has two parts. By the end of the lesson, you should be able to define pH, identify the pH range for acidic, neutral, and basic solutions, and explain the importance of pH in various biological processes. Let's begin Part 1. pH is a fundamental concept in chemistry and biology. It is a measure of the acidity or basicity of a solution. In this lesson, we will explore what pH is, how it is measured, and why it is important in biological processes. Understanding pH is crucial in various biological processes, such as enzyme function and other cellular activities. Buffers play a significant role in maintaining pH in the body, ensuring that the body functions correctly. So, let's get started. What is pH? pH is a measure of how acidic or basic a solution is. It stands for potential of hydrogen and is defined as the negative logarithm of the hydrogen ion concentration in a solution. pH is measured on a scale of 0 to 14, where 0 is the most acidic, 7 is neutral, and 14 is the most basic or alkaline. A solution of pH 7 is said to be neutral, because the quantity of hydrogen ions and hydroxide ions are equal. Solutions with a pH below 7 have a greater amount of hydrogen ions, while solutions with a pH above 7 have more hydroxide ions. The pH scale is logarithmic, which means that each whole number change in pH represents a tenfold change in acidity or alkalinity. For example, a solution with a pH of 3 is 10 times more acidic than a solution with a pH of 4 and 100 times more acidic than a solution with a pH of 5. A solution with a pH of 9 is 10 times more basic than a solution with a pH of 8 and 100 times more basic than a solution with a pH of 7. pH indicators are substances that change color depending on the pH of a solution. They are commonly used to determine the pH of a solution by changing color in response to the concentration of hydrogen ions and hydroxide ions present. The most common type of pH indicators are acid-base indicators. These indicators are weak organic acids or bases that are able to lose or gain a hydrogen ion, depending on the pH of the surrounding solution. pH meters consist of three main components: the pH electrode, the reference electrode, and the electronic meter. The pH electrode is a glass tube that contains a special solution known as the reference electrode. This solution is designed to maintain a stable and known potential in the electrode, which is necessary for accurate pH measurements. The pH electrode is sensitive to changes in hydrogen ion concentration, which determines the pH of the solution being measured. The reference electrode is a silver-silver chloride electrode that is immersed in a potassium chloride solution. The electrode generates a stable voltage that is used as a reference for the pH. Electrode: the electronic meter is the final component of the pH meter, which is responsible for converting the voltage generated by the pH electrode into a pH reading. The meter displays the pH reading on a digital screen or a dial. pH paper, also known as litmus paper, is a type of paper that is coated with pH-sensitive compounds. It changes color based on the acidity or alkalinity of the solution. In semen analysis, pH paper is used to determine the pH of semen. The normal pH range of semen is between 7.2 and 8.0. If the pH of semen is outside this normal range, it can indicate a problem with the seminal vesicles or prostate gland. pH paper is not as accurate as a pH meter.